Most of you guys have put like what you just ate in chat and when you ate it. This is pretty relevant because we're going to talk about digestion. So hopefully by the end of the digestion portion of the slideshow, you'll be able to like gauge where your the food you just ate is, because I feel like the digestive system, you kind of just like eat stuff, or at least I do most of the time, and I just forget about it, but it's actually a really interesting process. And then we'll go over metabolism and some of the myths about metabolism, because like a lot of people, I'm sure you guys have heard of or familiar with like diet culture and all that stuff. There's a lot of like myths behind metabolism and losing weight and all that stuff. So hopefully this class can give you a better idea of like nutrition, because there's actually a lot of like anatomy combined with biology in nutrition science. So it's not like we're analyzing food. That's not really what it's about. But so this week we're just going to go into digestion and metabolism, because this way in the following 4 weeks, we'll be able to go more in depth about the macronutrients like carbohydrates, proteins, and lipids. And then we'll go over micronutrients, which are kind of just like vitamins and minerals and the stuff that's not like super abundant, hence micronutrients. And then week 6, we'll do review. I heard you should not eat before swimming. Is that true? Actually, I didn't look up this myth, but I'm sure you could search it up and there'd probably be an answer for that. But yeah. Okay. Let me first admit someone really quickly. All right. Let's get started in. So before we jump into like human anatomy and how we digest food, I just want to briefly introduce the topic of nutritionism a bit. And anytime in the presentation or the slideshow, you can feel free to drop a question in chat to me privately or public, or unmute yourself, and I'll be happy to answer your questions. So I just wanted to introduce how we entered this quote unquote age of nutritionism, because food packaging didn't always seem like it didn't always look like this, and it's what we're familiar with because we were mostly born in the 21st century. I don't think any of you guys are born in 2010s. Actually, that might be possible. I'm not even sure anymore. But if you guys, are there anything like in this picture, is there something that's like something that you observe in this picture that's on all these food packagings? I think this is like the cereal aisle. Yeah, Kiana?
I have noticed that all food packaging happens to have a nutrition facts label,
Yeah.
and I assume that is so that people can see how much of this is in there, how much of that is in there, and it allows the government to regulate the food to make sure that it's appropriate to be put on the shelf, and it also contains ingredients, although it's not shown here, and that will help with knowing whether your allergy is in there, and it will again help the government know whether it should put it on the market.
Yeah, that's correct. And speaking of government, like Kiana, when you brought up government, that's actually really relevant to this whole nutrition thing, because not all food packaging looks like this. It's only in the US. So food packaging didn't always have all this nutrition facts. So if we step back about 50 years, like in the 19s and 60s and 70s, like it's been a little bit of time since America has come out of the Second World War. So what do you guys notice about these foods from the 20th century? Go ahead, Kiana.
They look a bit different.
Yeah.
And I've noticed that you can't really see the back or the side.
Yeah.
However, based on the fact that you can see the side on the Mary Baker one, I'm pretty sure that there's not really a nutrition label on there, nor an ingredients label. It's hard to see.
Yeah, because like basically, you can't really see, but in the 1960s and early 70s, yeah, Athena?
I see that sometimes, like, it's a little packed in there, and sometimes it could be hard to get the food out sometimes.
Yeah, yeah.
Too.
So like in the 1960s and the early 70s, like food was just food. Like they didn't put how much protein or carbohydrates was on the package. Like that wasn't really a selling point. And yeah, the food packaging is definitely pretty interesting from what it looks like now, and it's pretty different. So how did we really get here? It's just been 50 years. That might seem like a long time, but it really isn't, because there's been a pretty dramatic change in this food packaging. So just gonna give like, yeah, a brief crash course of like 1 year or a very little time in US history. So this is the year of 1977, and basically there was an alarming increase in chronic diseases like heart disease, cancer, and diabetes. And heart disease, cancer, and diabetes, these three chronic diseases are all linked to diet. So basically, this is like the alarm part. So to take action, this guy named George McGovern, who is the senator of South Dakota, and keep in mind, this will be important. South Dakota has a lot of cow farmers, so keep that in mind because this will become relevant in the later part of this story. And basically he formed this Senate Select Committee on Nutrition, which is basically a bunch of senators that come together and hope to improve the nutrition for Americans. And they published this document called Dietary Goals for the United States. And it basically, what they concluded from data was that after World War II, the rates of coronary heart disease in the United States increased dramatically. And on the other hand, cultures that had diets that emphasized more of like plants, they had really low rates of chronic diseases. And they also noticed that during the war years, when meat and dairy products were severely rationed, heart disease rates also decreased. So putting one and one together, this dietary guideline basically recommended to all Americans that they should cut down on red meat and dairy products. So who do you guys think wouldn't be very happy about this? Athena, do you have an idea?
The American people?
Yeah, be a little bit more specific. Remember who? Yeah, the farmers. Yeah, nice. The South Dakota farmers, the cow farmers in South Dakota, who this George McGovern guy is supposed to represent. He basically, these cow farmers weren't really happy because this McGovern guy is supposed to represent them, right? He's the senator of South Dakota, but he's recommending to all Americans to buy less red meat and dairy products, which includes cow milk. So he's basically like not helping their business. And as a result, the committee in McGovern basically completely rewrote, define chronic diseases. Chronic diseases are basically any disease that you kind of get over time. And the ones that we're specifically talking about are heart disease, diabetes, and cancer, which in this case were all related to American diets. And basically they completely—
The long term?
Yeah, over long term. Chronic just relates to like time. Yeah. And so this committee basically completely rewrote the recommendations, and they replaced their advice to reduce consumption of meat with, and I quote, choose meats, poultry, and fish that will reduce saturated fat intake. But what exactly are saturated fats? So the committee essentially just changed their dietary guidelines to please these powerful beef farmers. And as a result, Americans were taught to avoid these like invisible saturated fats. So saturated fats kind of became this like invisible villain because we don't really know what saturated fats taste like, but they're like found across our diet. So Through this class, I hope you guys not only learn about the benefits and restrictions of various nutrients in our diets, but also the biological processes that happen in our body, and specifically what happens to the nutrients that we eat after we put it in our mouth. So in order to better understand these biological processes, we have to first look at how digestion and metabolism in our body works. Oh yeah, so somebody asked a question. Basically, this recommendation by McGovern, it was for all of the United States, so it would have affected not only South Dakotan farmers, but farmers like across the nation. But basically, as a result of what McGovern did, he was not voted to be senator in his next term because, as you can guess, these farmers are really powerful and they make up a lot of the population of South Dakota. But back to digestion and metabolism, and also you guys would probably search this up, but there's also like some beef, no pun intended, between Oprah and the beef farmers like community. So she basically published this documentary and they basically just didn't like it. But yeah, that's like a totally different topic. But anyways, we're gonna go over the digestive system first. Kiana, do you still have a question, by the way? Okay.
Oops, must have forgot to put it down.
No, you're good. Just wanted to check. But yeah, we're going to go into the digestive system, which is just mostly going to be about anatomy and biochem. So digestion is really just the complex this is like a definition from Google, but it's basically this process of turning the food that we eat into nutrients that our bodies can absorb, and these nutrients can then be used for growth, repair, and energy that we need to survive. Obviously, we need energy. So that's why a lot of people have a saying, or like a lot of people follow the saying that food is fuel, because it's really true, because food is what provides the energy to survive. So digestion, like we just read about, is the process of breaking down food to be absorbed or eventually excreted or pooped out. And the gastrointestinal tract, or the GI tract, or the digestive tract, is basically just this passage or tunnel which our food passes through. So like this diagram shows, it's basically a tube within a tube. And the trunk of our body is like this outer tube, and the GI tract is this inner tube in our body. So that's why it's like, in this diagram, the digestive tract is like the cylinder within this larger cylinder.
The blue one?
Yeah, the dark blue one would be the digestive tract. And technically, actually I'll get to that next, but technically, like this the second bullet point says, it's technically outside of our body, because if you think about it, our mouth is connected to like the outside world, and everything that follows after that, although it's inside our body, it doesn't directly go into our body. Like when we eat food, it doesn't just like go into our blood system. It has like this large intestine, the small intestine, and eventually by the end of our digestive system, we just like excrete it out. So our food never actually really enters our body or the trunk of our body, because it's, if you kind of think of it like a water pipe in our house, we don't actually, like, there's not really water in the house or our body. In this case, the house representing our body, like the water is just kind of passing through it, and we'll have faucets or like shower heads in other places for when we need to take out water, which is kind of like how in our digestive system, some parts of our digestive system will absorb nutrients from our food as we need it. But for the most part, our food doesn't really actually go into our body. And all the nutrients that we get that we don't produce ourselves have to be absorbed from this GI. And if nutrients are never absorbed by the GI, they will eventually just be excreted out of our body. And in other words, they just never enter our body, which is pretty good for us. Maybe this is something about evolution, but that's really good for our body, because this way, if you know, a lot of the things we eat, there's probably lots of bacteria and things that we don't, and antigens that we don't really want in our body. So this just kind of minimizes the possibility of us getting sick. But because we're human, we're still going to get sick sometime. But that's more about our immune system. So let's go back to this digestive system. So the digestion journey is quite a long one, and it starts with our mouth and it goes through our esophagus, our stomach, our small intestine, our large intestine, which also can be known as like the colon, and also our rectum, and eventually anything that our body doesn't need just comes out our anus. And there's also three or four accessory organs that also play a role in digestion, but they don't really come in direct contact with our food. And these are our salivary glands, our pancreas, our gallbladder, and our liver. And okay, so let's go to the next slide. If you guys have any questions, feel free to stop me or put it in chat. So we're first gonna look at the journey from our mouth to our stomach. So digestion begins in our mouth, and digestion occurs both mechanically and chemically. So like we talked about, the salivary glands are basically these glands that can help us break down our food chemically, but mechanically we have our jaw, and mastication is basically this mechanical digestion, which includes us chewing and grinding our food into smaller pieces. And then the chemical part of digestion in our mouth is basically when the sublingual gland, which you guys, I don't know if you can see my mouse. Can you guys see my mouth? But I'm sure you can see it. The sublingual glands, shown in the diagram, is the smallest of the three major salivary glands. And why do we have to chew our food? It basically just makes it easier for us to swallow. Like, yeah, imagine swallowing like a whole sushi thing down, like a whole roll of sushi. Like,
how come snakes can do that then?
Easy. Yeah, we chew.
Yeah, I mean, eating an entire chicken is like hard.
Yeah, I mean, our esophagus can stretch.
But how come snakes can do it then?
Well, their digestive system is probably a lot more different, and our esophagus, there's a GIF later in the slideshow, and it'll show you how like your esophagus can kind of like expand a little bit almost to allow your food to pass through, but it really can't swallow, like it really can't, expand that much. What if you successfully swallowed an apple whole? I don't think it'd go very successfully, because our mouth, yeah, the tubes are not big enough for a chicken. Or yeah, Minecraft Steve has a much larger esophagus than us. But anyways, before you actually even take a bite of your food, your digestive system like already starts, because your salivary glands already begin to produce saliva. In fact, in a day, like your salivary glands can produce about 1.5 liters of saliva each day. So that's quite a lot of saliva. And that's also why drinking water is really important, because saliva pretty much depends on your water, because it's actually, I'm not even that sure what exactly saliva is made up of, but it most definitely what if you're immune to choking? Okay, I'm not sure. Everybody has like a reflex. Your esophagus would probably explode. Yeah, it's not that elastic. But salivary amylase, as it says here, so our salivary glands not only release saliva, but they also release mucus and enzymes. And so the salivary amylase basically, it breaks down the carbohydrates that we eat a little bit. So like Jenny put in chat earlier, she had a green tea bread. So when she's chewing it in her mouth, these enzymes are actually breaking down the carbohydrates just by a bit. And then the lysozyme enzyme basically help break down any bacterial cell walls. So this can help prevent infection, but once again, it's not always effective. And And then after you finish chewing with your mouth, the food is basically this small round of mass, which we call a bolus. And this bolus is actually a good size that we can actually swallow now, unlike a whole apple or a whole chicken. So this bolus starts after we swallow our bolus, it'll basically enter our pharynx. And as you can see in this slideshow, compared to our nasal cavity, like our tubes leading up to our stomach, like the larynx and the esophagus, and the pharynx are pretty thin. So that's why you can't really swallow that large of a bolus. Define amylase. Amylase is basically just, here, let's go to the previous slide then real quick. Amylase is basically just like an enzyme, and I can't really define it, but you could look at its structure online, because every enzyme has its like own unique structure that basically helps catalyze a reaction. And in this case, amylase helps digest carbohydrate a bit. And essentially what it does is it just like cleaves glycosidic bonds and starch molecules, but we can talk more about carbohydrates next week, because next week we're going to be focused on.
Wait, isn't your saliva like why that you can't chew gum too long or like disintegrates in your mouth?
I think that's true. Yeah, that's actually happened to me. I remember I was chewing gum for a really long time, and it literally just became liquid at one point. It was really disgusting. But yeah, I think that probably makes sense, but I'm not actually sure about that. But returning to the pharynx, the bolus will first move down to the pharynx, and then it reaches this fork in the road. So it has larynx as one option and esophagus as the other. So which road is it going to take? Well, obviously we do not want to choke. So the bolus is going to go through the pharynx. Or sorry, it's going to choose a path that goes to the esophagus. Because if it goes down the larynx eventually leads to the trachea and ultimately our lungs. And that's obviously not where you want your food or your drink to be going, because that's for the air you breathe. So whenever you like kind of choke on something, it's because your food went into the larynx. But the bolus is going to go through the esophagus, which will eventually lead to our stomach. And once it goes down our esophagus, this is the path that it should go. Our body actually has this really cool thing, and it's in the diagram. It's called the epiglottis, and this is basically just a really small tissue, and it covers the opening to the larynx or to the trachea. So this way, even if your food or your water does go into the wrong, even if it goes through the larynx, your lungs are not going to fill up with it. Like, it's not going to build up. Your food is, the little flap is going to help protect your lungs from the bolus going all the way down into your lungs. What happens if water goes through your nose then? Well, as you can see, your nose is like connected to all of this stuff, like your esophagus and your larynx. So it'll just go down your esophagus. Apollo? I don't know. Do you have a question, Apollo? Water is liquid. Yeah, that's why it's not going to go down your larynx, because that's for gas. Okay. Why does it hurt when you pour water through your nose? That's a good question. I don't know the answer to that. You should probably search that on Google. But anyways, we're going to move to the esophagus. So this is a really cool GIF, and it basically just shows what it looks like when your bolus is moving down your esophagus, which is like this pretty long tube in your body that leads to the stomach. Okay, give me a sec. All right. And so basically, your bolus will travel through firstly the upper esophageal sphincter. And sphincters are basically just these really cool muscles or circular muscles that are found throughout our digestive system. And they basically serve as like gates between our different sections. So basically, once our bolus enters the esophagus, as you can see in the GIF, these like wave-like muscular movements occur, and it basically just helps push the bolus down into your stomach really fast. And the lower sphincter, yeah, you can see on the diagram to the right, it basically keeps the harmful acids of our stomach out of our esophagus, because as we all know, stomach acid is extremely acidic. So if your lower sphincter is not very effective, or there's a little bit of leaking of your stomach acid, you might feel like a heartburn sensation, like below your lungs where your esophagus meets your stomach, because your stomach acid is so acidic. So yeah, if you ever feel like heartburn there, then you should probably get that checked out, especially if that happens to you more than once. You feel it a lot, because that's probably a good indication that your lower sphincter is not doing its job. And then let's move on to the next slide. So after it goes through the path of our stomach, of our esophagus, the bolus will enter our stomach. And like our mouth, our stomach also has both a mechanical and a chemical digestion process. So the mechanical is like similar to what our mouth does. It basically grinds and churns our food, and it produces this chyme. So we've moved from bolus to chyme. And chyme is basically, it's not solid anymore. It's a semi-solid substance that is partially digested. And after this mechanical part is done, or the mechanical and chemical parts of digestion in our stomach kind of occur simultaneously. Oops, I just logged out. Oh my goodness. Okay. Thanks for letting me know. While our stomach is doing mechanical digestion, it is also doing chemical digestion, which is a lot more complicated. So basically, our stomach walls, well, let's look at this diagram one more time. Look at the diagram, like our stomach has a bunch of layers, but we're mostly going to be looking at the inner layer, or the one that basically touches all of our food and does most of the digestion, which is the mucosa. Sounds like mucus. So the lining of the stomach has a lot of layers of tissue, and the mucosa layer is basically what helps digest the chyme. So mucosa is not flat and has its surface is not a flat surface, and instead its surface is lined by gastric pits. So this diagram is kind of like you're looking into the layer as if you like dissected the layer, and you can see these like dark pink pits, and these are called gastric pits. And gastric pits, basically, this is where we get really into biochem. So at the bottom of our gastric pit is where G cells lie. So the G cells, they basically secrete the hormone called gastrin, and gastrin basically just stimulates our other cells that are in this gastric pit. They stimulate the chief and the parietal cells, and if we go one more up, we hit the parietal cells, and the parietal cells basically secrete HCl. Does anybody know what HCl is? Yeah, hydrochloric acid. So it's an acid, right? And that's part of the reason why our stomach acid or our gastric acid is so acidic. And then one up from our parietal cells is called the G cells. And these G cells secrete pepsinogen and gastric lipase. So basically, I put it twice on here, gastric lipase, but pepsinogen is what helps digest protein. So that's a typo. Instead of gastric lipase, it should be pepsinogen. Pepsinogen helps digest proteins, And then gastric lipase helps digest fatty acids. And HCl also helps digest proteins. And then at the very top of it are the neck cells, and they just secrete mucus. And it basically just secretes mucus to help prevent the gastric juice or the stomach juice from digesting the stomach itself. Because it's so acidic, if it weren't for this mucus, if our stomach was just made out of purely acidic
Why are there
acid,
two gastric lipase?
yeah, that's a mistake, a typo. So it should be, it's the first one should be pepsinogen. So I'll fix that later. Let me make a Okay, so basically this mucus that's excreted by the neck cells at the very top of this gastric pit, they basically secrete the mucus, and the mucus protects the mucosa of the stomach from digesting itself, because stomach acid by itself would basically, it would like digest the stomach layers. So we have to have this mucus in order to protect the stomach. And okay, next. This is kind of like a scale of all the acidities and everything on a pH scale. So the lower the number, the more acidic it is. And as you can see, gastric fluid, which is also known as stomach fluid or stomach acid, whatever you want to call it, really. Gastric fluid is basically one of the most acidic things out there other than battery acid. But gastric acid is, all you have to know is that gastric fluid or gastric acid is just basically secreted by the neck cells and that we just talked about. So they're at the very top of the gastric pit. And this is a really cool histology of our stomach lining, or like the tissue layer of our stomach. So it's just a closer look at the mucosa, so you can see like the big gastric dips. And just like a side note, histology, if you guys are ever interested, is like a really cool field you can go into. And if we have time at the end, I can introduce histology to you guys, or you can ask about it if we're over time. But histology is really, really cool because you can look at the chemical components of things, and you can, like, after you dissect stuff, you can basically use histology to look at the chemical components of stuff and identify things. And also a bonus is that the imaging, or these images that histology produces, are really, really pretty. So if you have free time, just like search up histology and images, and it's pretty cool. So now we're going to move on to the small intestine. And this diagram doesn't really show it well, but it's not that dark blue thing. It's actually inside that large intestine. The small intestine is inside it. So it's right where that like target is pointing at. Let's go next. So basically the small intestine is like the primary site of digestion. Contrary to popular belief, our stomach is not like the primary site of digestion. It's actually our small intestine. So the small intestine is divided into 3 sections. We first have the duodenum, and then the jejunum. Okay, we need to redo the pronunciation. The duodenum, the jejunum, and the ileum. So this small intestine is a long tube that's loosely coiled around our abdomen, and if we spread it out, it'd be more than 20 feet long, which I'm sure is much longer or much taller than you guys, maybe even 5 times more, or 4 times more. You guys are probably like 5 foot tall. Yeah, so it's really long. And so after leaving the stomach, your chyme enters the first part of the small intestine, which is the duodenum. And the small intestine is basically the major place for all digestion, like I talked about, but it's actually the jejunum and the ileum that are responsible for the absorption of nutrients. So this is really important. So the jejunum and the ileum are basically they're basically responsible for the absorption of nutrients, and when they absorb the nutrients basically just go into our bloodstream, and eventually our liver then purifies this blood. But basically, yeah, our blood carries all these nutrients to anything that needs it. And then it's our jejunum and our ileum and our small intestine that basically like take out the nutrients from our food. But before we can continue with the small intestine, we have to visit the pancreas, the liver, the gallbladder, all of these accessory organs, because they're really important and they work together with the small intestine. So let's look at those. So the first one we're going to look at is the pancreas. And the pancreas is basically like hiding behind our stomach, and it has two different portions. So we're going to focus mostly on the part that basically produces pancreatic juices, which are produced by acinar cells, but that's just kind of like a detail. And the pancreas basically produces pancreatic juice. Go to the next slide. And the liver's main role, pancreatic juice. Yeah, it's called juice, kind of like how we call stomach juice. And then the liver also has a really important role because it basically produces bile, and bile is basically just this like greenish yellow fluid that is mostly consisting of bile acids, and the bile produced by the liver is then transported to the gallbladder. So as you guys probably know, like liver also can purify blood, which is important. Like it purifies the nutrients that are in our bloodstream and just our blood overall. And bile is also really important for the digestion of fats, which we'll go more into in the 4th class. But the gallbladder is basically where the bile goes to after it's made in the liver. So the gallbladder is like this really small, like sac-like organ. And if you look down here, it's that like little green little sac. It kind of looks like an ink sac. And basically, it's found just off of the liver. And its primary function is to just store and concentrate bile made by the liver. And then after that, the bile is transported to the duodenum through the common bile duct, which is also in the diagram. And so it just basically transports, after it's like concentrated the bile, it'll transport this bile to our small intestine, which can then help use this bile to like digest our stuff. So when you're eating, actually, the gallbladder already knows, and it just contracts and it sends some bile to our large intestine to kind of get ready for us to digest food. So then once all the nutrients have been absorbed, how does it know? Your brain. Yeah. So once the nutrients have been absorbed and the leftover liquid has passed through the small intestine, because the small intestine basically absorbs all the water, or like, yeah, like the fluids that are in the chyme. What is left of the food that you ate is then handed over to the large intestine, which is next. And the large intestine is this dark blue thing in this diagram. How does your brain know? Gosh, I don't really know much about like our brain, but it's probably has to do like our brain being able to like signal and tell our different organs what to do, because your brain does do a lot of things subconsciously. So our large intestine, relative to the small intestine, it's like wrapped around the small intestine, and as you can see, it's a lot thicker than the small intestine, and it's just like right below the stomach, but it's also right before the anus. But the large intestine basically consists of 3 parts. So the 3 parts are the colon. It's kind of misleading because sometimes, yeah, mainly for poop. Yeah, it makes the feces basically. It's the last part. It's kind of a little bit misleading when the large intestine is referred to as a colon, because your large intestine actually also consists of the rectum and your anus. So the large intestine, its main function is basically to absorb any remaining water that the small intestine didn't absorb, because the small intestine doesn't actually absorb a ton of it. And it also absorbs any electrolytes like sodium, potassium, and chloride that our body needs a little bit of. And then it basically forms and then eventually excretes feces. So the large intestine contains a lot of microorganisms. So this is kind of like a close shot of the microorganisms in our large intestine. So large intestine can also be referred to the gut, by the way. So there's a large number of microorganisms that are found throughout our digestive system, but the majority of them are in our large intestine. And as we saw in the previous one, the colon, this diagram, the colon can basically be divided into 4 parts, which we'll go into now. But yeah, these are like the little microorganisms that are living inside our body. So we're not the only thing that's living in our body. So as you can see in this diagram, the colon can be divided into the cecum, the ascending colon, the transverse, a lot of different names. But our colon is about 5 to 6 feet. So it might even be taller than you are. And it basically connects our cecum. Basically connects our cecum, which is the first part, to the rectum, which is the last part of the large intestine. And here's just some like explanations for the name. So the ascending colon is on our right side of the body. On the diagram, it's on the left, but if you were to look down on your body, it's on your right. And the transverse colon basically just goes across. So it goes from right to left, right to left. And then the descending colon basically goes down, and it's on the left side of your body. And then the last part is your sigmoid colon. So I don't know if you guys are familiar with Greek letters, but the S shape it's called the sigmoid because the Greek letter for S is called sigma. And the sigmoid colon now connects to our rectum. So as it says on the slide, stool is what passes through the colon. So first we went from bolus, and then we went to chyme, and now we're at stool. So stool is basically just waste that's left over from the digestive system, and it usually just contains of bacteria and food debris that our body does not need, and it usually does not have that much nutrients left. So the stool is what passes through our colon, and it's stored in the sigmoid colon, the S-shaped part, until a mass movement empties it into the rectum once or twice a day. And mass movement is not referring to when you're taking a poo, it's just a mass movement. But it normally takes about 36 hours for your food to be turned into stool and go through the colon. And when the descending colon becomes full of stool or poo, it basically just empties everything into the rectum. So we can begin our process of excretion. And someone asked a question, why is the large intestine named the large intestine when it's shorter in length than the small intestine? I think it has to do with its relative thickness, but that's a pretty good question. Yeah, it should be like the short and the long intestine. That's probably makes a little bit more sense. But the rectum is basically just like this 8-inch chamber that connects our colon to our anus. And its only job really is to receive stool from our colon, and it'll tell our brain that there is something in our rectum that needs to be evacuated ASAP. And it'll basically hold on to the stool until we're ready to excrete it out or for it to be released. And when anything, it can be gas or stool, comes into the rectum, sensors basically send a message to your brain, and then the brain then decides if you can release the gas or the stool at the moment. So basically, if you can poop or if you can fart at the moment, then the sphincter muscles relax and then you can excrete whatever it is. But then if you're in a situation that you really can't go to the bathroom or you can't fart at the moment or release gas, the sphincters will contract. So temporarily that feeling goes away, but eventually you're going to have to release it because it's in the rectum and it can't come all the way back up. So yeah, that is the rectum. And this is the anus. So the anus is just the last and final part of our digestive tract. And the internal sphincters basically keep us from going to the bathroom when we are asleep. A question you probably have is like, then how come like babies pee and poo in their sleep? Maybe they do. I don't know. I'm pretty sure they do. But it's probably because their internal sphincter is not developed completely. But basically, the internal sphincter will make sure that we don't go to the bathroom when we're asleep, or otherwise when we're unaware that there's stool there. And when we get the urge to go to the bathroom, we rely on our external sphincter, which is closer to the hole. We rely on our external sphincter to basically keep the stool in before we can actually go to the toilet or wherever you're going to the bathroom. I don't really know where you're going to. Yeah.
Or
but,
a porta potty or something.
Yeah, a porta potty, or maybe you're camping in the woods. Who knows, really? But this is basically like a timeline of your digestion. So this is kind of why I asked you guys in the beginning to put like when you ate your food, so you can, most of you guys ate food like about an hour ago, so your food is still going to be in your stomach. But if you're eating
I
something,
just ate food, so
yeah, so if Sienna, if she's eating food right now, the first 10 seconds, it's going down your esophagus. And then after 3 hours, it'll go into your small intestine. And going through your small intestine takes about 6 hours, or it takes about 3 additional hours. And then once we get to our large intestine, it'll take another very long time. So maybe another, oh my gosh, I'm getting a phone call. Okay. And then it'll take a total of about 36 hours. So it can spend as much as up to 30 hours in your large intestine. So typically, like the average that I read about is that it takes about 36 hours for food to completely digest and then come out. And yeah, so most of your guys' food is probably still digesting in your stomach, but the food in your large intestine is probably from yesterday. So I feel like that's kind of like a misconception that you like poop the stuff from like 24 hours ago, but it's actually a little bit longer usually. So this is just kind of like an overview of the digestive system that we just went over. So it's a lot of parts, and there's a lot more in-depth things that we didn't get to cover because we don't have enough time, obviously. I don't even know if we're going to be able to get to metabolism, but that's okay. Yeah, I think we should just skip to the Kahoot instead because we have like 8 minutes. So we can go over metabolism next time. So let me share the Kahoot slide. How old is everyone's liver? I'm not sure. Here's the Kahoot. Okay. So this Kahoot is actually going to have a little bit about metabolism, which you guys haven't learned yet. So I guess I'll give like a really brief crash course about metabolism while we wait. So basically, metabolism is not like what I feel like we read about. Metabolism really is just like any chemical or biochemical reaction that's happening in our body. And usually it's classified into 2 different types. There's catabolic and anabolic reactions. So anabolic reaction or catabolic reactions is kind of like what we talk about in the digestive system. Catabolic is basically breaking down things and producing energy. And anabolic reactions are basically like forming things. So an easy way to remember this is ABBC, just how I remember it. So like anabolic, build, and then break down, catabolic. That's kind of how I remember which one is associated with which. But anabolic reactions build, and so they basically build stuff that our body needs, and catabolic just reduces it. And catabolic reactions aren't that efficient. So like if you have 100, out of the 100% of stuff that our body breaks down, only 40% of the energy that's produced from breaking down stuff is actually directly transferred to ATP, which if you guys I'm not sure you guys are familiar with, but ATP just equals energy. And the other 60% of the energy is actually just like released as heat because they're not that efficient. Is everybody ready? I'll just start. I think there's 13 now. Okay, we'll just start. And here we go. And yeah, I think that's about all you guys will need to know. At the end, there's going to be like really quick myth or facts. I kind of wanted to like bust the myth buster, bust some myths. This is really fast. Okay. Yeah, so first it becomes a bolus, and then it becomes a chyme, and then it becomes a stool. So it goes in alphabetical order, B, C, S. What is more acidic than stomach or gastric acid? Right, it is battery acid. Lemon juice isn't even acidic as our stomach juice, hence why we're able to eat it or drink it if you drink lemon juice. Kahoot feels really empty without music. But anyways, yeah, it goes to the pharynx. The larynx is what leads to our trachea and then eventually our lungs. Okay, that's just like a vocab or a term. Nice. It's gastric pits. Mucus pits, not quite. It's only the top of the gastric pits that produce mucus. Yeah, so this diagram is not the answer. It's just the liver on this photo. Yeah, it's the gallbladder. It's often overlooked when we think of our digestive system, but yeah, I guess it plays a pretty crucial role, even though it's really small. This is a quick question, so not much time. Nice. It's our rectum. The small intestine comes before the colon because the colon is part of our large intestine. I think we're almost at the myth or facts. So remember, anabolic, as you see on this picture, a lot of people who are building body mass or muscle will eat anabolic like steroids. So that's why I chose this picture. So if you're going to build something, what are you going to need? You're going to need glucose and energy because you're building stuff. Glycogen is the reactant. And what was green? Green is water. Not really. Our body doesn't really produce water. We drink water. This is a pretty cool picture. It's just like a thermal energy of our body. Yeah, 60% of our body of the energy that catabolic reactions produce is just released. Okay, myth or fact? We don't really get to go over metabolic rate or no, 50-50. It's a fact. So basically, the best way to increase your metabolism, like our metabolism is mostly, for the most part, it's determined by our genetics. But if you want to increase it, you'd want to increase your muscle mass. So cardio does not really increase your metabolism, which I feel like is a belief some people have. Yeah, I chose a wrong answer, but nobody got, okay. So yeah, it's it's a myth. When you eat less, your metabolism can actually drop because you're eating less, and so you have a smaller calorie intake. And actually, this is kind of because like our bodies are built for survival, and so when you're eating less, your body might be like more alert and be a little bit more conservative, so your metabolism can actually decrease. This is indeed true.
Oh no.
Yeah, so you want to get more than 8 hours of sleep per night because do you guys want all the science, the nitty-gritty? I wrote it down. Do you guys want to hear about it? I'll just go over it really quickly. So basically, if you don't sleep enough, your glucose levels and your hormones levels that are important in metabolism can be like a little bit messed up, and it can decrease your leptin levels, which are basically the hormones that reduce your appetite. So because you have less of this hormone, you're going to have an increased appetite, all because you didn't get that much or as much sleep as you should have. Monkey.
Oh no, I clicked the wrong one.
I wouldn't be so sure. We clicked the wrong one. This is this is a fact. I feel like I didn't really know that this was a fact, but
I thought red was a fact, so I clicked instead.
yeah, basically they contain this like chemical compound, and it can increase the calories and the fat that you burn, but like it's not that much. Like it's pretty insignificant. So last question. Yeah, it's a myth. Eating the time that you eat doesn't really matter. It's more about what you eat. So like at night, you'd want to choose a snack that contains items that can be easily digested. So like a lot of people would eat like yogurt or cottage cheese. I'm not a fan, but cottage cheese if you like that. That's an easily digested item. Nice. Okay, so I'm just going to conclude now. Okay. So yeah, that was it for today. We didn't get to go over metabolism, so I think I'll cover it just a little bit next time. But thank you guys so much for